we are going to learn that also today. Then there is creating gray image to the binary image or only 0-1 image. Then the filter, like one of the Instagram filter beautification, which we are going to learn today. Then we are going to learn about like how to convert an image to the drawing, hand drawing or sketch drawing. Then there is a basic background removal using OpenCV. Then there is a feature matching without using any like a machine learning algorithm, without training, how we can know like one image is available in another image or not. We are going to get based on that also. We are going to learn panorama image staging. In our mobile phones, we click panorama image, right? So we are going to learn that also today. And at the end, we will learn two more things, which is like how to remove background from the video, and we will load some deep learning models, like heavy models, into OpenCV without using any other external libraries. So yeah, we will talk less and we will do more coding today. Okay? Yes. Oh, is it visible from behind? So, okay, so the first thing is like how to install the OpenCV library. In Python, to install OpenCV library is very easy. We can use pip install OpenCV as Python. It will install the latest version of the OpenCV library in our browser, in our code. Then we are importing some libraries like CV2. CV2 is stands for like computer vision 2. So we are first importing that library. Then NumPy. NumPy is like using array in other languages. So we have to use it, and CV2 also as a base uses NumPy only. So we don't have to install NumPy. If we install OpenCV Python, it will automatically install the NumPy. There are other libraries also like Colab and all of those things, but those libraries will be only necessary if you are loading it in Colab. If you are not using Colab, then it's fine. There is no need to install the Colab by Python base64 process or request or something like that. Okay, so let's see. So there are some base functions which we have created. First one is to download something from the URL. So we have created some images and videos and models. To load those images, we are going to use a request.get module, and we will download those in a path. And then the stack images. Stack images, we are like there is one image in there. We are horizontally stacking multiple images to showcase. So to do that, what we are doing is like we are edge concatenating those images. It is one of the OpenCV function which we can use to concat multiple images in side by side and display it for better visualization. When this thing will come, I will ping you. Then the second thing is FFmpeg. So we know like there are many codecs in videos. Like MP4 is one of the codecs, 8265, 8264. All of those are different codecs. But all of those codecs are not supported in Colab. If you want to make it web streamable, then it must be of like 8264 or WP80. So we are using FFmpeg to convert those videos into WP80, so we can easily play those videos inside our Colab or any web browser. And in OpenCV, if you want to use it as an inbuilt, then you have to build it from the scratch. Then you will get the FFmpeg library, and you can use this internally also. But as of now, we have not built the OpenCV, so we are using FFmpeg and converting all of those MP4J videos into WP90. Yes. Okay, so let's start with some core functionalities like reading and writing images. Scroll. Yeah. So first we are downloading one image of a flower from this link, and to read some image in OpenCV, we are using cv2.imread, and we will give the path of that image. It will support almost all of the images, image formats like a TIF also it supports, which are for iOS users. And there is one function CV2 underscore IMSO. Underscore IMSO we are using it for collab. And if you are using in Windows or Linux or any other, then CV2.imso under other than IMSO. So this is the image which we loaded. So in mobile phones, we know there is one functionality of cropping some images from some certain area. So here we are cropping one image. So first we copied the old image because OpenCV is reference based language. So if you do some operation on this image, it will be affected in the original image. So we are first copying it, so we can use this image in later on in our article. So there is one functionality which is called shape. Shape will give us like what is the dimension of the image, height, width, and channels. So here we can see there are 3 channels available. So these 3 channels are like R, G, and B, red, blue, and green. So how much percentage is the green, how much percentage is the of red, and how much of the blue. So its range it's from like 0 to 255. If all the pixels are 0, that means the image is completely blank, or the pixel is completely blank. And if all of them are like a 255, then that pixel is completely white. So here we are taking some random dimension like 300 and 500 to crop that image. So to crop that, what we need to do is like we just need to pass the starting x, ending x, starting y and ending y, and just pass it, and it will crop that part for us. So here we can see we got one crop, and from the same we got like 820 is the height, and 1094 is the width, and there are 3 channels available. There are some images which consist like 4 channels also, and some contains 1 channel also. So can anybody give me an example of like what is the 1 channel and 4 channel? Yes?
Grayscale image would be 1 channel.
Yes.
And depth image would be 4 channels.
Not the depth image, but anyone else? Like where the 4 channels are there?
Images like PNG which contains the alpha channel.
Yes, exactly. The PNG channels contains the alpha channel also, like how much is the transparency over there. So that is the alpha channel, and mostly the PNG images contains that. Scroll. Okay. So there is one more functionality of OpenCV where we can split all the channels differently. So we are currently splitting BGR 3 channels. Using CV2.split, we just need to pass the image, and if there are like 4 channels, we have to pass over here 4. If there is 1 channel, we just need to pass 1 variable over here. And we can do some operation with those channels also. And we can merge those channels using the CV2.merge. And OpenCV supports BGR only. So any image is loaded by default, it will be in BGR until unless you convert it into other formats, which we'll see later on. And so here we are taking 2 images. Here we are taking 2 images. First one is the original image, and second is like our merged channel image. Let's scroll down. So here we can see both the images are same to same, right? So let's do one thing. Let's reduce our red channel to half. So here when we converting it when we are doing like multiplication division operation, we have to use convert scale absolute. So what it does is like OpenCV only supports integers 0 to 255. So if it is not in integer, then it will convert that into integer, and if the range is more than 255, it will convert it into 255 only. Like if someone does like 1000 multiply by 1000, then it will go beyond like a 255, right? So at that time also it will scale it up to 255 only. Scroll down. So yeah, here we can see the result. The red effect is reduced. Okay, let's do one thing. Remove the red color at all. Multiply by 0. So yeah, now you can see the blue color dominated the image because the red is become 0, so blue become the dominant one. Let's do one more thing, like make blue also 0. So you can see whole image is now only green color only there. Other color are 0. Let's remove green color also. So what it will be now? Correct. So we can see all pixels are gone because all channels are live 0 now. Anyone want to do any other experiment with this one? Like changing color or something like that. Let's do one more thing, like instead of BGR over here, do RGB.
Oh, 111.
So here we can see it converted into blue. Because our red color transferred to the blue color, that why blue dominated it. Well, let's do one thing, red into 1000. Yes.
That is it. BGR to कर.
You can see wall color is blue because we have given blue to the red and below, that's why give BGR only.
कंट्रोल एंटर से होता है.
Yes.
The change of the pixel is from 0 to 255. So how we can multiply it with 1000?
Yeah, if we multiply with 1000, whatever value will be, if it is like a 500, the result we will get 5000. It will give it 255 only. It is kept to 0 to 255 only. So whatever greater value will be more than 255, it will be converted to 255 only, the max value. So here you can see wall image is mostly converted to red. Just do one thing, other colors 0, only red is 1000. So we can see this effect also. Yes. So we can see most of the image is converted to red, except for few pixels over there. If you can see, can you zoom in?
नहीं था.
So yeah, here you can see one small spot where we got black. Anyone have idea like why this part is not converted to red?
Because it had no red. Red was 0.
Yes, exactly, because red was 0 and whatever we multiply with it, it will always be 0. Okay, let's load one more image, it's the PNG image. So here we loaded one PNG image and we can see the shape. Scroll down below. So yeah, you can see 3 channels only, but recently we talked, right, that PNG must have 4 channels. Then why there are 3 channels only? Anyone using OpenCV know about this thing? Yes?
Because we are reading in a BGR format, not BGRA format, like for A for alpha channel.
Yes, exactly. Scroll up a little. Yeah. Here we are loading it IM read only. But when we are loading any image with 1 channel or 4 channel or more channels than 3, then we have to use IM to unchanged. So it will not change the channel values. Else the OpenCV what does is like if you are loading gray image also, it will give all three RGB the same gray values. Yeah, scroll below. So yeah, we have to pass I am read unchanged. Scroll. Yeah. Now we got 4 channels over here. And we know like it is a very crisp image other than the above one where we got some pixelated results, right? Okay, let's do one thing. Let's put this bee on that flower. So yeah, here we first loaded the flower image, then the bee image. We copied both of them, and then what we did is like we splitted the bee image, and we know like a bee image of 4 channels R, G, B, and A, and we know that like a alpha channel is like a how much the transparent it is, and as per result we scroll about. Yeah, all the white pixels which we are seeing are actually 0 as a alpha channel. The alpha channel of all these white pixels are 0 right now. That's why we are saying it right. So let's do one thing. Let's extra. If we want to crop this B from this image, then what we have to do is like we have to take that alpha channel only, where the alpha channel is more than 0. Those part only we have to consider as our B image. Other part we have to remove it from the ground, because else if we just put this image onto our flower, it will get some part as white. It won't get that background here, background color. Yeah. Oh. So the first thing which we done is like we cropped one part of the flower where we want to put our bee inside. So we have got one starting point like a 0 and starting y as 100, and as we understand yeah, how to crop, so here we are cropping that part of the bee. Can you show that both the things like alpha channel and I'm so scroll up. Okay, so this is the alpha channel of the bee image, where we got white pixels where the bee is present, and black pixels where the bee is not present, because we only extract the alpha channel. That's why this color is black and this color is white. And above we loaded is as a RBGA. That's why it was a reverse. Scroll a little bit. And this is the part which we cropped from our flower, where we want to put our bee on. Yes, go on the code. Okay, we sort the B image. Now what we are doing is like we are doing bitwise node. So when we apply bitwise node on any image, what it will do is like it will divide that image from 25. It will subtract that part for pixel from the 255. So like if the our as per our B image alpha channel, we know there are only 0 and 1s. So 1 will become 0 and 0 will become 1. It will be get reversed. So the alpha negative. So yeah, this is the result which we got. We will understand like why we done the negative thing. Okay, and then we are doing a bitwise AND operation. So what bitwise AND does is like it will take both the pixels from the both the image, and it will get the maximum, the minimum pixel whichever over there is, and we are applying one negative mask. So when we apply any mask, the operation will be only done on those pixels where the value is 255 or 1. The pixel value where 0, the operation will not be done. So what we are doing is like we are taking one flower area and another flower area, and those part where the our white area was there in negative image, it will be totally blank, because we are not doing any operation over there. So it will become 0, whatever part will be there. Can you show the bitwise AND operation? Yes, you can see over here. So the masking, whatever white part was there, at that time they have taken the minimum value of both the things, the flower, but both the values were same, so we got the same pixels. But where the mask was not present, they have kept it as a blank. So we can put our B now over here, which part we have cropped. Go below. Yes. So now in B, if we are taking alpha channel also with us now, then it won't get merged, because to merge both the channels, to do operation, both the images must have the same channels. If one have like a 4 channel and another have 3 channels, it won't get operated with each other. So we have to only take the RGB part, we have removed the alpha part from there, and from there we have added both the images. Sorry, first we cropped the B images and then we added both of them. Can you show the final result? Okay, so here we can see the final result looks like this on the cropped part. Now the thing is, we have to put this cropped part on our main image, the main big image. So to do that, we have to do same thing which we had done in the cropping. So in the cropping, what we are doing is like we are assigning one cropped part to the image. Here what we are doing, we are assigning the cropped part to the image pixel range where we want to crop. So here you can see the starting point and ending point, and scroll
Outside. Right.
right. Here we applied the cutout area. The operation will be reversed to the cropping when we edit. And so the final result. Okay. We can see there are a few problems. The first thing is like B is in left direction instead of right direction. So let's flip it to the right direction. Go to the top. Flip. So there is one command in OpenCV where we can flip in horizontally or vertically the image. And the B size was more also, like a very big. So we are reducing it to the half. So to do that, we can pass like how much we want to reduce to the X and how much we want to reduce it to Y. And if we have some number in mind, like I want to convert it to 150, then we can pass it over here, like 150 only. Then it will convert it to that and it will resize be the same size. So you can see all the images are changed. Okay, yeah. Now it looks like it is going over there. Okay. Any question on this thing? Okay, let's move to the next one. Okay, we currently learn about RGB. There are 3 channels. It's the same way RGB, there is one more, we can say color space, which is HSV. Scroll down. Scroll down. So yeah, this is HSV. So in RGB there is one problem with us. Like if we can go anytime from like a red to blue to green, because we are only adding the pixel values of 3 numbers, and we don't know like what will be the exact color in the last one. It may become magenta or purple or something like that. To solve that, they have created one HSV image where only the hue is the changing the color, and saturation and value are dependent on the how much the lighting will be there and how much the saturation is there. So let's check the first hue. Hue is the color. It will be like a 360 degree, like from 0 to 360. It will be the same color in 360 and 0 also. So it is separated in that way. But in OpenCV we are getting like a 170 only, because all the OpenCV operations are int 8, and int 8 supports maximum 255. So we cannot go beyond like a 255 because it will be heavy in computation. So what they have done is like they have kept it until the 170. Sorry, 179, 0 to 179. Then there is one saturation part. The saturation means like how much it is unrelated to white. If we are adding some water to some color, it will become a white. It will lose its main color and it will become more like a transparent color or something like that. So that thing is saturation, like how much saturated or how much concentrated the color is. And then last thing is the value. Value is like how much lighting we have given. If there is one bright image also, like a white, bright black, bright yellow color also, but we are not putting any light on that thing, it won't get brighter and we won't be able to see its right color. So that's the value we can say. So how much lightning we are putting it on that, Like if we see some funky color, funky clothes in gym or all of those things, or high visible jackets, they have value like upmost, they have highest value to see it from the distances or far. So that's the value. So that is the HSV role. V means like how far we are from the black, and saturation means how far we are from white. And their range is like a 255 only. Yes.
notebook full screen नहीं है.
notebook room boy
Okay, here we are again loading our flower image, and above what we have done is like we have splitted it and we have converted those colors into RGB to BGR. But there are some operations also like a color BGR to RGB. It will directly do those things for us without writing very long codes. And here we are stacking both of those images to represent that. Yes, go. Yes, scroll.
title
Scroll. Load करना जो बना बने. So here we are downloading a few of the videos and few of the images for our next applications. Anyone know how green screen works? Yes?
You can just remove green color from the screen.
Yes, exactly.
That green color will be
So we just need to remove that green color. And green is the in HSV cycle, it is the most brightest color which we can see. That's why we are choosing green colors only. And its value range and saturation range is very good to fix because of its strategic placement in HSV. So here we are loading one video. Can you show that video only?
link
Okay.
નામ શું છે
Ursula. Yes.
वो क्लॉक आउट है ना इसका पाथ શું છે
So here we are loading one of the videos which we have recorded of a green screen. We have taken one green bag with us and we are showing it around. Yes, it is downloaded. You can load.
કંટ્રોલ જે
नहीं. Loading છે. કેવલ HSV માં.
અરે
કેવલ HSV. Okay, so here you can see one green screen like thing over there which you are putting.
હિલતા है
Okay, so first what we done is like we have loaded the video. As we load like a video image, I am read. To load video, we can use video capture. If we have like a RTSP stream, instead of this path, we can use RTSP stream also. If we have webcam also, then we can use that webcam index 0, 1, 2, 3 or whatever index of the webcam directly, and we can stream from there also. Then we are reading the first frame. So as the first frame, we are considering it as our background image, which we need to extract, which we need to show after the on that green part. So that what we are doing. Yeah, we are getting like a height and width of the frame, like BG image. Then we can get the FPS of the videos also, like how much FPS we are streaming. And if we are streaming on video, we can set that FPS also because we cannot do like a live streaming on 60 FPS or 30 FPS in a computer vision. So we can reduce it to like a 5 FPS, 10 FPS or something like that for that purpose. Then there is a 4cc, which is like a video codec. We are using currently MP4V codec, which is of MP4 codec mostly. And there is one of the functionality of OpenCV where we can write the video also. To write the video, we need to give the path, we need to give the codec which we want to use, FPS and size. So here we need to take care is like this size must be like similar to the out which we write the frame of. I will explain that. And these two codecs must match. So if we are passing it MP4V and if we pass over here AVI, then it will not write over there because the extension and the codecs are not matching. But yeah, we can use H264, H265 also because those are also the codecs of MP4. So yeah, here we are while looping and we are reading the frames. To read the frame, cap.read is there, and then from there we can get one rat and one frame. So rat is like is the frame is existing or not. Maybe the video is completed or corrupted or something like that. Then rat must not be there. So we can break our loop from there because the video is completed. Okay, so the first thing which we are doing is like we taken the frame and we converted that BGR image into HSV image because now we want to work with that green screen and removal. So in BGR we cannot work it because we have to fix those channels in how much value of green, how much red, and how much blue. But in HSV we just have to set the S and V values only because V value we know like we have a green range. So green range is very much fixed over there. So we are creating one mask from that from our HSV. We will get one lower color and higher color. So here we have fixed lower color to like a 3080 and 100, and our upper color to 80, 166, 188, 180. We can set these two. We can play any much with these two one like saturation and values. But for view we have like a very strict rule. We have to limit that color in the same range only, else other colors will also get distracted. So first we created one mask, then we have created the negative mask as we have done with that B image. So this mask will give me the range, give me the mask where the green screen is only. Other pixel will be the black and only that pixel inside that green screen is there, it will be the white. In a negative masking, it will be the reverse thing. Then we are adding our background, then we are extracting our background from that green screen only. We are taking the background only because we have applied mask over here. So all the white pixels will be there and black pixels will be removed. And we got result 2 as like our other part where the green screen is not there. So in one side, result 1 what we got is like background where our green screen is, and the second one where our green screen is not there. And we are fixing both of them as a add weighted. We are adding both of them as weight 1. So this is one more method where we can use weight also, like from first result how much weightage we want to give, and for second one how much weightage we want to give. Like if we give it weighted to the 0, it won't add any pixel. If we get 0.1, it will add a very little bit pixel, or we can say like the pixel value into 0.1. And we can stack the result also. Can you show the results of this? Scroll up. Okay, so here you can see the person is standing with this green part. This is the mask which we extracted of green, and we are applying our background over here with that green. It won't look that much good, but as a beginning of OpenCV, we are using these applications of HSV. And film industry also, where we see those special effects, they are also using the same techniques. Instead of the background, they are relaying something else over there, like some say scenographic waterfall or something like that. Please play the video also. Which anyone know the name of the invisible cloak in Harry Potter?
उसका नाम भी था
No one knows. This is Jola. Thing is like converting grayscale image to binary image. So here we are seeing one image where we are not very much reading every pixels because those are mixed of grays. So we have to, for some text detection or recognition, it is becomes easy for them if it text only is in like 0 and 1, and it takes less processing power also to compute other than like colored fonts. So we can trace that image and convert it into white and black only. To do that, there is one method called thresholding method, where we have to apply like from which pixel to which pixels, from which range to which range we want to give it like a front one or back. So here what is this is like if the pixel value is less than or equal to 100, then it will be the black, and if it is between 100 to 255, it will be the white. So it is just as the if else only. But for image we have to, it is very long array, so we can't do like if else for all the pixels. So it does in matrix format, so it is faster one. And if we apply, if we give this image to the other text detection algorithm, so we have to, so it won't have to like handle all the colors, and it will be very fast and efficient on browser and edge devices also. So this is one of the use cases. Next. Okay, now perspective transform. This is very good use case. So in some areas we see like if the match is playing in Dubai and there people are like watching. So if someone shows an ad of a Jio in Pakistan, Jio in Sri Lanka, it is no use of Jio, right? It is waste of their money. So they can use feature like this to apply the change the banner or the ad completely in different regions while playing the match in the banners or all of those things. So here is one of those use cases. Here I am taken two videos. First one is the New York street video where there are many ads and many banners are there. And second one is a waterfall, AI generated waterfall. So what we do is like first show the video of New York street. नीचे ऐसे जो नीचे जाओ स्क्रॉल कॉलम में स्क्रॉल okay, so here we can see ऊपर ले जाओ
वीडियो में
डाउनलोड ठीक Okay, so there is one video of New York street where there are many banners and many ads are running. So what we will do is like we will take one of the ad out of that and we will add our own ad or our own video and we will play over there. So let's understand. Okay. So to do that, scroll. Until here we are just creating one video and capturing both the video frames. We need two types of points. First, first points of the video which we want to place. So here is the video place. So we are adding like a 0 0 means the starting point of the video, and height width means the ending point of the video, and in between there is a width 0 and 0 height. So we can get the whole video captured in another one. And the second point is like where we want to put that video on. So we just don't want to put it like that, right? Because in perspective, if we see anything, it have like a lines like this, in this and this, like this. It won't have always straight lines or orthogonal lines. We always see everything in perspective. If you are seeing from there to here only, everything will be in perspective view. So we have to convert it into perspective. So that's why we can use a find homography function, where we just apply both the points for the first point and the second point. So here the thing is like we need minimum 4 points to find one plane related to another point. If we have like more points, that's also fine. It will give us better result for that one. And from here we can get an edge. Edge is like how much is the translation, how much is the rotation, and what is the scaling of the final video, for which we had given the point. So yeah, from here what we have done is we had started both the video rendering, the first video and the second video. If we have the frame of both the videos, so it is a very long video, so we are doing it for only 100 frames only. So there is one more function which is warp perspective. So whatever height width, whatever the translation we got, like translation, rotation, scaling, we just pass it over here and we just pass our frame. So it will give us perspective view of that thing converted into another video or another size. So in AR applications, if you are seeing, they are placing some object on another objects. They are putting 3D objects on another table also or something like that. So in all of those methods, they are using warp perspective. So they are changing the perspective of the original thing to match it with our destination one. So let's see one warped image, how it looks. So yeah, here is our one of the warped image. So it was like a straight one, but now it is converted to slightly affine one. You can see over here. Go to the right here. Okay, so we got that. We have created one blank image, complete blank image. Then we had applied fill convex poly. So what this one is if we provide some points to that function, it will fill that points with white pixels or whatever pixel we want to fill. So we just need to pass some points over here, and it will fill that complete area. So currently we are filling that with 255. So here there is one thing, we can't use the functions which we have used before for O-ring or masking one, because our points are not in some trajectory, it is different. It is currently like a rectangle, then we can use, but if it may be star also, it may be like a hexagon also. For that we have to use fill convex poly to fill that mask completely. So we have filled that mask and we have negative that mask. Can you show the masks and convex poly? So yeah, this is the convex poly where all of the pixels got white based on our 4 points. Scroll down, and this is the negative. So what we will do is for this part we need that waterfall area, and for this part we need the New York part. So we will combine both of those in one. Go up. Okay. So here what we are doing is we are doing one AND operation on both of them, like first frame and second frame. Here we are not applying that mask one which we have applied so because we need to merge both of this one. If we apply negative mask, the place we want, it will get blanked out, and other part will be the New York Street. So that the part also New York Street area bitwise that.
Okay, image is big.
Yeah, you can see over here. So there was one ad playing over here, but now it is blanked out. So we will put our video over here as the ad. Go over the top again. Okay, so we have done the bitwise end. Now we are merging both the results. The first from the waterfall only, and the second one where our crop out of the area where our waterfall was. So we are doing that, and we are taking all of those images as a video to see how it looks. So yeah, here we can see we have replaced this part with our ad or our video. So my video. Play the video. So now we can see instead of New York, we are playing one another video which is like a waterfall. Yes. Any questions? Yes. Yeah. To do that point, we can use OpenCV's point method. In Colab we can't use because we don't have window. So once window open, we just click on those points. Like this is the first point, second point, third point, or fourth point. But when you work with industry or something like that, the camera is fixed and advertisement boards are also fixed. So you will get those points beforehand, before running the live stream or something like that, because those are fixed and camera only rotates. And based on that, we can do calculation like where the point will go. Any other? Okay, so the next one is like when the AI was not discovered this much, where the template methods were working. It is example from that era. So let's see. So here is one diamond card, like our this card, and there is one diamond template also. So what our task is to detect these diamonds from this image. So for that, to do without like using open machine learning or heavy models or something like that, we can use one simple method which is the template matching, where we just need to pass our base image and our template image. And the method which we want to use, currently we are using coefficient normalized method. From this one result we will get like okay, what is the minimum maximum values and what are these locations where that template is placed. Based on that we will look over all of them and we will get okay which one is this. And we can set one threshold because it will detect multiple, as we detect multiples in AI also. It will give us multiple images, so we can set a threshold like okay how much threshold we want to set. So currently we threshold set is 0.8. So all the images which math score more than 0.8 will be there. Can you see? Okay. So here you can see these diamonds are detected, but this one are not detected. So anyone have any idea like how to improve this and detect these diamonds also? Yes.
You can take a filter which determines diamond and basically take it over the entire image and convolute it with that.
Okay. Okay, so the problem with the template matching is like it won't work with all the sizes and shapes. So to detect this one with only using template matching, we have to resize the image multiple times. Like divide first we do it with the full image, then we divide it by 2, divide it by 4, divide it by 8, and we will aggregate all of those results into one image. So this was the era before the AI and computer vision was very, very good in training. Okay, now the next one is biliterate filter or smoothing the areas. So here we are using biliterate filter to smooth out anything. Most of the like beautifications and all of the Instagram, Snapchats are using these kinds of filter. So here what we do is like we provide one image and we give the 25 is like how far we are going to see it. If we are in convolution, so what is the size of the convolution network? Then 30 and 30. First one is the standard deviation of the pixel and the second is the effect of standard deviation. So the first pixel, how much effect will be in first, second, third, one, fourth, until we got the 25. So it is based on that. So the image. So we are using biliterate because it is based on standard deviation. So what good thing about it, other than using like a median filter or other blurring functions, it will keep all the edges as it is because it is a standard deviation. So whatever deviation will be there, it will keep it as it is and it will only change those parts where the standard deviation is not there. So if you see these prickles are like removed, but some pimples are still there because of that edge detection. Okay, the image gradient. Someone who have attended the previous lectures also, they have got to know about like horizontal and vertical convolution networks which we have used to detect like how many horizontal lines are there, how many vertical lines are there, and all of those things. We can do this using Laplacians or Sobel method. So this is also one of the gradient based method. So it will take a center 3 by 3 matrix and it will check in all the direction. Okay, which one is the less, which one is the greater. And based on that, it will create one magnitude. How much effect is there? So based on that, it can check. Okay, if this is the edge or not, edge of image or not. And the second thing it will check is the direction, like in which direction the magnitude is going, like from east to west, west to north, based on the center pixel and all the 9 pixels which we have checked. So based on that, there are two methods of a Sobel. First one is like a Sobel X and second one is Sobel Y. So we can play over here. The first one is represents X and second one represents Y. If we want to detect like all the X and Y mixed, we can give it 1 also. There is a k size of 5. So as I mentioned, there are like a 3 cross 3 matrix. We can use 5 cross 5 matrix also for better results. And based on that, we can get a better magnitude and direction of the pixel flow where it is flowing. So yeah, here we can see this one is not very good visible, but it is Laplacian. So we have many of you have heard about it in 12th standard or 10th standard, but maybe never have used it in real life. So it is using the same Laplacian based method, and these two are using gradient based method to match the gradient flow, like which side the gradient flow is going on with the pixels. Any doubt on above? Okay. Okay. So here we are taking one images of Sudoku again, and we are converting into grayscale, and we are doing a Kenny edge detections. So many of the AI algorithms also use the edge detection flow. So that is loosely connected to this Kenny. So they are also doing these things. So Kenny is one type of filter, where the middle pixel is like a brighter and other pixels are negative and positive, 1 minus 1, 1 0, 1 minus 1 in that way. So we can find all the edges of the image when we do the convolution on the image. So based on that, we can create one Kenny image. Scroll. So this is mostly used in like a detection on AI applications. Before, like we can use it in pre-processing also for AI models. And the basic application of this is like a children's color book, where we can put some images and we can generate only the sketch of those, and children can draw or fill the colors on those things. Okay, the next thing is someone has mentioned, right, the grab. They are using Google Meet to remove the background. It is the similar kind of thing, but very lightweight thing. So here what we are doing is like there is one flower kind of things. We have to select one area. Those who are familiar with the Photoshop, they know in previous days they have to draw some area. Like I want to remove this area only. They use the tools. I don't know the name of the tools, but they used to do the rectangle box and mark that area. Okay, I want to extract this object, and Photoshop used to remove other background from that and only give the foreground to. So that one was using GraphCut algorithm for this thing. In GraphCut, what we need to do is like we need to load one image and we need to give one some points, 4 points, like from which area to which area, which object we want to keep. Scroll up. Scroll. Image. Scroll. So yeah, here you can see one image. So we have to do a rectangle from here to here or here to here somewhere. So it will check, okay, what are pixels inside and whatever pixels are outside. Based on it, it like extracts the background and foreground separately. Go in the code. Okay. So here we are just like taking all the zeros, so we can get a black image. Scroll down. Here we are taking few points of that thing and check whatever inside we have to capture it only, and whatever is outside we have to left it as a background. scroll. Okay. Based on this grab cut, we got first the image. Second is the mask. Mask is like we have drawn from those 4 points, a black mask. Based on that, it will grab. There is one rectangle which we have given all the points, and background model and foreground model, where we get the outputs, then some values to check the threshold. Okay, what threshold we want to keep it with for GC and for traveling of the image. So if it is the range is far from that, based on the pixel values, so pixel values will be in a gradient in bell curve form. So whatever will be in center, we will check bell curve from that point only and go far from that. Yes, below. It will create us two masks. If it is like a 0 or 1, then it is a background, else it is a foreground. So here we are just multiplying it with the mask, so we can get the extract. We can extract the foreground. Go. So here we can see this part is removed. Let me check. But you can see this part is not still there. There is one black stick over there, which is not extracted in our part. So this is one of the drawback of this grab cut algorithm. It won't understand this thing is also part or not. It is solely works on based on the bell curves and pixelated values and range. So for this thing, we have to use AI only to understand which part, which is the part of the image or which is not the part of the image. Because if we do this for person, maybe our most of the hair will be not there, because it will lose the bell curve function and it won't get inside the threshold. Yes. The next one is the feature matching. Most of us are aware of CGIs, right? So CGI is loosely discovered from this feature matching only. Before they were using like a QR codes on. Before they were not using the sensors of IoT, they were using QR codes all over the body, and they were based on this feature matching only. They used to check, okay, which object to render over here, which object to render over here, or where is the face, where is the hair, and all of those things. For feature matching, there are many algorithms: shift, solve, orb. So we are currently here using the orb method. So to use feature matching, we need one image, we need one object, and that object placed in some place. The same thing we are currently mostly doing with AR/VR, where we scan our table or we scan one book, and when we scan that book again, we get one object plotted on that. So that features is also based on this. So here we are first creating one object, and based on that, we are extracting features from both the images, first image and second image. And then we are matching all the features, how much similar both the features are, like from the first image to second image. And whatever matches we got, we store them. Can you show the results? Okay. So here you can see the features. So ORB mostly gets the features based on the ones where the lines are not there, whereas the edges are there. It only takes these corners and all of those things only. Corners, circles, triangles, those are the very good features. And orb and all of those things mainly takes those features. Because in here, we are not learning any model or anything from the data. We are just taking some features. And before the neural network or the value function was discovered, scientists used to discover this type of features, like, okay, triangle is one of the features, circle is one of the feature, and based on those features only the detection went to happen before the value was discovered. And based on this image key points, we just draw it using draw matches. Any question on this? Okay, the next application is panorama stitching. We capture multiple images of same area with a little bit of difference, and we merge it. And many of our phones cameras also do that. using multiple cameras. They just teach those images to make it a larger view or give us a more angle, like a 140 degree, 160 degree, or whatever degree we want, based on that. So to do that, we are having few images of a bot. We are just taking all of the images and appending in images. We are just showing those images. Please show those images. Okay. So these are the different images which we have captured with some phone or camera, something like that. Go to the code. We are creating one stitch or create object. Then we just stitch all the images. Can anyone know like what algorithm they are using over here to stitch the images? Okay, in above application we seen one odd detection, right? So it was looking for all the matches. It was looking for corners and triangles and circles and all of those things. So this algorithm also uses the similar method. It finds all the key points in all the images and checks, okay, in first image where are those points, in second image where are those points, and checks, okay, these are matching, these are matching, these are matching. We got all the matching points. Then it uses the one of the more application which we will use in perspective view. It transforms its perspective based on those points and fits it. Then third image it takes and then also it fits it. So it does all the application which we learned until now. All of them are used to develop this panorama stitching. And based on those key points matched, we can get one stitched image. Any doubt? Okay, so here we are removing background, static background, because most of the time when we use anchoring or something like that, or Google Meet also, our background will be the static. Only we are the one who are changing. So we are creating one code for that to only change the background when the camera is static. We are first loading one video, so we are taking the first frame out of it to mark it as a background. Then go scroll down. Okay, so here we have taken the second frame of the video. What we have done is like we have subtracted what was in the first image from the second image. So we got the rest of the things with us. So based on those rest of the things, it won't be like a purely white and black. It will be in a gray set because we are doing subtractions. So if one of them value is like a 255 and another one is 200, then we will get 55 value. But we want either 0 or either 100, either 255. So based on that, we learned one thresholding while learning about Sudoku, that we can give one value. Based on that, it will convert us only the white and black masks. So here we will get one white and black mask only. And based on that white and black mask, we can just merge both the images from our area using that mask, and it will give us a video where the background is removed. Can you show the video? Here you can see there are 3 cars are parked. There are cars are detected over here. Video download 3 download. Output result as हम अपने थे क्यों बाकी चीज़ फर्स्ट पहले चलो. Okay, so this is our background frame, you can say. So whatever part will be here, it won't be displayed over here because it will remove these parts because it is subtracting those parts. Now black. The black, it is visible from behind or not? So here we can see all the cars only detected. This is the last applications. We are using one external model also. So in CV2 we are loading a YOLO V8 model because as I mentioned, maybe this YOLO is not comfortable with all the languages like Java. If someone want to work with Java or C#, we don't know like there is a Torch or a YNX or those libraries are available in those one or not. So we can use OpenCV in anywhere. We just like train our model in Python. We just export that model and use that model in any of the languages where we want to use. So here what we have done is like we have taken the base S model of YOLO, which is given by them. We have converted into ONNX format. Once we converted into ONNX format, we can load it in OpenCV using DNN module. So here you can use readnet from ONNX also or readnet also. So readnet it's all type of format like PyTorch, TensorFlow, whatever format you can give, it will read from all of them. Then we are giving input and all of those things. Here we read the bus image. Then what we done is like we have created blob of that. In everybody know like in YOLO, before passing the image to the inference, we have to do some pre-processing type, pre-processing things. So here what we are doing is we are doing pre-processing. In our image will be in 255 only format, integer format, but YOLO won't understand because YOLO model is 0 to 1. So we are dividing it with 0 to 1. We need to resize also. So we are resizing it to 640, 640. And then the last one is like swap red and blue. Scroll. Swap red and blue. In PyTorch or Pillow, if you use, it is based on RGB. But when we use OpenCV, it is BGR format. And whatever model we use in PyTorch or YOLO or whatever, those are mostly using RGB only. So here we have to swap the R and B to become RGB to BGR. Yes. And then we have to like net.set input block where we are passing the block and our old favorite forward method in any of the AI technology, which will give us the predictions. Now we got the predictions, but yes, but a prediction will also not be in like or say which we want 640, 641. We want it will be in 640 in a result 281, 281 or whatever result will be there. One index will be in last. To understand in here or to easy looping, we have to swap those channels. We have swapped those channels. Scroll. Yeah. From here we are like looping over all the predictions which we got. We are extracting those predictions. We are extracting confidence, which class it detected, min max location like from the classes score. Scroll. Yes. Yes. Here we got like from row 0 item height, x, y and height width of the image. Then we had done some post processing of the image because our base image, the result which we got, it is based on 0 and 1 only. It will be normalized, but our image is like large. This result will be based on 640, 640 only. But our actual image is not 640, 640. To understand for YOLO, we had provided it into 640, 640. So here we are doing post processing to convert it back into the base format which we want for our main image. Yes. So, here we are doing NMS boxes to reduce those boxes which are like overlapping with each other on the same object. And then we appended all the class IDs, confidences and boxes. And then we drawn the rectangles around those objects which are detected. Scroll. Yes. Scroll. So here we can see we are able to detect all the person from here using YOLO V8 model in OpenCV. So yeah, thank you everybody for the listening. Okay, so today we started with the basic of OpenCV, like how to read and write the images. Then we got into like how to manipulate those pixels of RGB, gray, and HSV, and all of those things. Then we learned few applications of like a green screen and image detection. And from those base we are able to do the panorama stitching also. Because panorama stitching needs more application. Like we need to learn perspective also for that thing. So we need to use multiple cameras and all of those things. And at the end, what we done is like we have used currently most famous Euro V8 model inside our OpenCV. So it can be used in any of the languages which we are familiar with, without skipping the language, and we don't have to force it to make it only to the Python. Thank you all.
Yes, a big round of applause for him. Thank you, sir. Yes, so as we said in the beginning that this is just 0 to 1 in this session for computer vision, and for me and for I think the kind of people like me who are not much into this AI/ML, we feel like it is 0 to all. It was that much in depth, and to cover it in 1.5 hour session is really commendable. Again, thank you very much, Hiren, for all the efforts you have put. Now, for the next part, I would like to call Hiral Kotadia. First of all, I would like to tell something about her. Like when we started these sessions before 3 months, like we were always thinking that we don't want to limit with this. We want to start a community, and the result itself we are seeing today. Because of the efforts we have put behind the community, we are seeing more interested people today in this session, and we are seeing all the new faces as well. So to bring all of you on the page and for this event, like she has put a lot of effort starting from the day one. She initiated the idea of this kind of meetup. She had worked a lot on preparing all these WhatsApp groups, this LinkedIn profiles, this meetup profile, and how we got that meetup account and all. I would like her to tell that story and get our all interest in that. But first, a big round of applause for her for all the efforts she has put. Over to you.
Thank you. Okay, so first of all, meetup and the session was completed. So don't worry, put smile on your face. હું વધારે તમને બોર નહીં કરું. મારે સિમ્પલ 4-5 વસ્તુ શેર કરવી છે. Before that, I would like to mention the word part of the global AI community. When we started the idea of the meetup before 3-4 months, at that time we set our mission and vision. What we'll do. That was very simple. Our main aim is to learn and grow together, right? We will never promote any other HR related or any other company promotion related activities. So our aim was clear that we want to educate the people and we want to learn and grow together. But we were finding some reason that what next. અત્યારે માર્કેટમાં એવી કઈ વસ્તુ છે કે જેને ટાર્ગેટ રાખીને આપણે આગળ ચાલી શકીએ કે ભાઈ મારે 2 વર્ષ પછી મારી કમ્યુનિટીને આ લેવલે જોવી છે. So for that we were searching for different community of AI all over the world, and in that search we found the one name is Global AI Community. Basically that is established by Microsoft, and we after that research we got to know that that is encourage the small communities all over the world. Right now they have 30 plus communities registered with the Global AI Community, and we are part of that Global AI Community. From India, we are third community who is the part of the Global AI Community. 2 other communities are in, I guess, in Bangalore or Pune, and in Gujarat we are the first who is the part of this Global AI Community. Okay. If you found that our event page and at the end of that event page there is a sponsored by Microsoft. This is the reason why there is a written that sponsored by Microsoft. So right now Microsoft is sponsoring our these meetup accounts as well. They are promoting our events in their page as well. They are promoting in their community page and community website everywhere. after that they have around I guess 35k plus 35 35,000 plus followers of that global AI community, and they people are promoting our every event for that 35k followers. So right now this is limited for our Ahmedabad group or Ahmedabad region, but in the near future we will definitely arrange some online meetups which will be target all over the world and all over the global community. So this was how we found the global AI community. After our first meetup, there is a one founder of that community who is a Hank Boltman. So we got touch in that person and we share our meetup ideas and our vision and mission, all these things. As well, we shared videos and photos of our past two events, and they was very happy to know that some group is doing such activities and at very early stage because this is our first meetup. So before first meetup, they approved to be a part of the global AI community. That was a very good achievement for us. Okay. The thing is, base is ready with us. We have backend, we have a few AI supporters, we have the platform where we can do the such events. We have everything. Now to grow further, we need mainly two things. One is volunteer, and second is speaker. For volunteer, there is nothing to do hard things, just to arrange the meetup and simple works you people are doing that. Some few volunteers are doing over here. So we need few volunteers as well speakers. Apart from that, I found many non-AI people also over here, and many AI people are also over here. So we suggest you to share the topics which you want to learn. You read somewhere in the newspaper or somewhere in your social media or anywhere. If you find that topic is interesting, then you can submit that topic to us. That I don't know about this topic. I am not the speaker. I don't know anything. But it would be great if you can arrange the meetup on this topic. So you can either suggest any topic. If you are interested as a speaker, as I in introduction, a few people told that they are speaker and they are much in AI part. So they people can apply or contact us to become a speaker in next meetup. And if anyone is a many people are non-AI peoples, they might be gone in another meetups. So if you find anything interesting that that community does, और यू फाइंड सम इंटरेस्टिंग दैट मैं वो मीटअप में गया था, वो ये चीज़ बहुत अच्छी थी, तो जो भी ऐसा कुछ भी है जो आइडिया आपके पास है, प्लीज शेयर. राइट. सो मेजरली वी नीड योर सजेशंस. We need your suggestions on topic, some ideas that we can implement further in our meetups, and we need speakers. Okay, so this is what right now we need as your support. And the last thing, that you might find the QR codes over here in desk. This is our AI meetup. So all the photographs of the today's event we will share with one AI platform. The people who are coming first time, they might don't know that every time we are sharing the all photographs instantly with the one platform that is based on AI. So with using of this QR code, you can download that application. In that application, you need to join one group. Last slide. Okay, so in that application, there were two options, that is a join group and create group. You just need to join group with this code. So all the photographs of today's event you will get there. And from that, by using a face recognition, you will get your photos separate. So if we all will share 500 photos, then by that face recognition, you will get your 5 photos separate. So, okay, or you can, you can search, if you are not able to scan this, then you can search the name of application, that is memorylens.ai. Just go to Play Store or App Store and search the memorylens AI, and you will get the application. Yes, the name of application is memorylens AI, and both the platform, Play Store and App Store.